It's excellent to have such a diverse group. You know why? Because today we're going to be talking about taking charge of your data science career. First, of course, I will tell you why data science career is so exciting. But second, and before we start, which actually became somewhat of a tradition, I want to ask you a question. What is a data scientist? You guys come from a variety of different countries. You have a variety of different backgrounds. So why don't you share with us your understanding of what you think a data scientist is? Or you can just say what a data scientist does. If you are here, you're obviously thinking about a career in data science. So let's talk about that. A problem solver. That's an excellent, very, how do I want to say it? Very over-encompassing term. Excellent. It's a problem solver. Anyone else? Modern term, work for statistician. Well, you're running ahead of me here a little bit. Yes, a statistician is one of the proposed common terms for data science. We'll talk about why it's not widely accepted yet. Modeling and analyzing data using math, computer science, statistics, and economics. Very good. You guys are good, but I already know that you're good. We have seen each other now a few times. Someone who can interpret a lot of data and processing it for optimizing a given platform. Also very good. So we have met before a few times, and I already know that you guys are good. A researcher who analyzes various data, presents an overview about collected data with conclusion, making useful insights from data, finding trends and patterns. Data scientist is someone who uses scientific methods, algorithms, and systems to track out knowledge and insights from data. Excellent. What I'm going to do with your answers, these are all very, very good answers. I'm going to hold on to them to the end, and we're going to come back to them. Because today we're going to talk about what the data scientist is and why this term has become so confused. Okay, so we are going to start with what is a data scientist. Then we're going to move to introductions, and typically do it the other way around, but I want to talk about what data scientist is first, and then for those of you who don't know me yet, I will tell you why I think I'm qualified to tell you about data science. So the introduction comes second. Then we'll talk about data science tasks. What does a data scientist do? Because being a data scientist and doing data science work means two very different things sometimes, and not just two. Broadly speaking, 5 different jobs, completely different jobs. So we'll talk about that. Then we'll talk about data science education. How do you find a perfect program? Each one of you has a career in mind, and each one of you wants to find the best program that's suited for that career. So it is important to find a program that is uniquely suited for what you want to do. And then, of course, we'll talk about some unique aspects of Master of Data and Network Analytics, which is the host of today's webinar. So let's go ahead and start with what is a data scientist, okay? Now, I'm asking this question because the term has been somewhat convoluted over the years. It traces back to 1974, when Peter Naur at that time urged for a different name for engineering science. Computers were, notice 1974, computers were not spread out yet. The computers were those big machines, and they required engineers. Well, that's what those people were, to work with those big machines. So those big machines store lots of data, or stored lots of data on very large disks. I'm sure you have seen some of those photos from 1960s when people were wheeling in a hard drive about as large as a house that could hold 5 megabytes of data. So of course, at that time, engineers were involved with working with those big machines so that we could store that data. Now, what happened next? data science was used interchangeably with computer science. So once the term came up for engineering science, it was called data science because we needed engineers to help us store all of the data, right, on those large machines. So data science meant computer science. That was one and the same. And that's why computer science departments still offer data science degrees, okay? And we'll talk about the differences. But data science used to be computer science. And what happened then? Well, we'll talk about what happened then and why, but now this term is often applied to business analytics and sometimes arbitrary use of data. So we started with 1974 when we had engineers and just end up with any use of data, all called by the same term, data science. Now, the terms that we get lost in large quantities are data science, data analytics, data analysis, data engineering, statistics, and then you can just name them all. And by the way, there is a difference between analytics and analysis. Can anyone tell me the difference between analytics and analysis? If you can't, that's perfectly fine, because I think that those differences are a little bit made up, but they do exist. And I'll tell you about that. So the terms that we get lost in sometimes transfer to a different understanding of what is data analytics versus data science. I'm not claiming accuracy of any of the sources I use. I just found them. I Googled them just to see what do people say. So when we look about data analytics and versus data science, okay? Since data analytics is arbitrary use of data, right? That we call data science. In data analytics, it's called data querying versus data science is data sourcing. Now, is there any difference between querying and sourcing? Now, data wrangling versus data cleansing. Again, we all have to clean our data, right? Statistical modeling versus data modeling. Now, if anyone can find the difference between statistical modeling and data modeling, I would be eternally grateful. Then data analysis versus results evaluation. Now, in data analytics, you also evaluate results. And then data visualization, results testing and deployment, you do visualize results with data science and you test and deploy results with data analytics. So this comparison is somewhat misleading because different terms make it sound data science work as more sophisticated, even though the tasks listed on the left are practically identical to the tasks listed on the right. Now, here's another picture. So we will put a question mark on that, right? We're not sure if we like that. Now, here's another diagram. We have programming, mathematics and statistics, and domain expertise. On the intersection of programming, mathematics, and statistics, we get machine learning, which is actually quite accurate because machine learning is nothing more than good knowledge of statistics, which you then implement as algorithms that machines utilize to process lots of data quickly. Now, between programming and domain expertise, there is data processing. I would question this intersection because I don't think it's data processing. I think it's something else. I'm struggling with the term a little bit, but I would really put it in as more of a hypothesis formulation of some kind. And a question that came in, what is domain expertise? Domain expertise is when you belong to a particular field. For example, in our program, we had physicians, a medical doctor who is an expert in medical field. And then we had several lawyers, they're experts in their law field. We had linguists, and then we had some people who were studying like foreign languages. I mean, it's a little bit different from linguists, but they are experts in the languages that they study. They're not really interpreters. They're more like language experts, right? So it's a branch of linguistics that I'm not very familiar with. So basically, you have a field that you're really good at, political science, anything else, all right? So when you have this domain expertise and you learn how to program, I do not think these two overlap unless you have some kind of what is called statistical research, which is you have a hypothesis to test. But anyway, regardless, data science is put in this intersection of mathematics, programming, and domain expertise. And I would tend to agree with that part. So I do think that there is a good portion of mathematics and statistics, even though you can teach it very differently, without heavy focus on math and with a focus on applied knowledge, then some programming, some domain expertise. But again, a questionable approach. All right. Now, there are more. For example, this particular one is data science skills versus data analytics skills. And here we have computer science, machine learning, software development, big data software tools, algorithm development. I tend to actually agree with this breakdown. So a lot of what data science originally was, remember computer science or engineering science, really involves these heavy computing, machine engineering related skills. Now, data analytics is data analysis software of many different kinds, data management systems, different databases, business intelligence, data visualization. Now, there are lots of things in between, like statistical analysis, programming language, data mining, problem solving, data storytelling to a non-technical audience. So I tend to agree with this particular description a little bit more, even though I still think it is limited. Again, we'll leave it with a question mark. Now, here is something that is very surprising. We have data science that includes data analysis, data analytics, and data mining. Now, perhaps that is true, but I think that's a little bit of a stretch. And here's another one, where data science is data analysis, research, and machine learning. Machine learning is operationalization and optimization, and data engineering is advanced programming, distributed systems. Again, somewhat simplified. And have you noticed that by now we have talked about so many different definitions, and we're still talking about data science, okay? So why did this confusion appear, right? So in some companies, fields, or programs, anyone is a data scientist, regardless of what they do. I did a search on Headhunter for a term data scientist. And if not for the shortage of time, I would have shared with you some of the job descriptions. It's fascinating how different they are from each other. Now, I got a message that you do not hear me. Do you hear me?
Yes, okay. We can hear you.
All right. Okay. So there is just one. Thank you very much for the feedback. There was a problem with one person. So I think there's probably just for that one person, there is something going on with their computer. All right. So you can have so many different definitions of the job that it's amazing how can so many different jobs be called one thing. All right. So here's almost a joke. A data scientist is a data analyst who lives in San Francisco. All right. Now, where it all started. It started in November of 1997 when Jeff Wu gave the inaugural address, Statistics Equal to Data Science, for his appointment as a tenured professor at University of Michigan. There he said that statistical work is a trilogy of data collection, data modeling and analysis, and decision making. Now, he was the one, again, it's 1997, who initiated the modern non-computer science usage of the term. And he advocated for statistics to be renamed into data science and statisticians to be renamed into data scientists. Now, I don't know how this one inaugural address has spread out, even though Jeff Wu is a well-known scientist. This particular proposition may not have taken life of its own if not for William S. Cleveland. We'll talk about that in a second. But so in 1974, there was this proposal to generate a new term called data scientist that was related to computer science. And about 25 years later, just under 25 years later, there was a proposition to rename statistics into data science. Okay, so
Dr. Kuskova, may I just stop you because you have some noises from your microphone?
Okay, there is static. Okay, is this better? Do we still have static?
Yes.
Okay. Let me continue to talk because some people say no. It is disturbing. All right, let me try to unplug a few things. Maybe the charger. Okay, is this better?
No.
Okay, so what I'm going to do is I'm going to connect again with a different computer and a different microphone. Just give me a second, okay?
Okay. Guys, while we wait, you can ask any questions and I will help to answer them. Why data science field is booming across the world? Okay, we have Valentina.
Yes. Oh,
No, don't worry. Yes, you can get video recording in our YouTube and also in our page with recordings. I can share it now.
okay, let's try this. Can you hear me?
Yes, it's better.
Excellent. Okay, so I think I fixed the problem. So you see me on one screen and you hear me on another. I apologize for the problem that we haven't experienced. Well, I mean, this is, that's technology, okay? And we have some issues. Thank you to all of you for sticking with me through this technological issue. All right, so we have stopped at where Jeff Wu has created this a little bit of an issue, but maybe it would have been okay without this inaugural address, right? Computer scientists might still disagree that statisticians are data scientists, but it actually got worse, right? Here's William Cleveland. He's a professor of statistics and computer science at Purdue University at Indiana. He did something worse than Wu, right? In 2001, he has published a book called Data Science: An Action Plan to Expand the Technical Field of Statistics. He actually equaled those two terms. Jeff Wu proposed that statistics and data science were used interchangeably, but Jeff Wu actually called for it. And he is the one, William Cleveland, is credited with conception of data science as a separate discipline, extending the field of statistics to incorporate computer science. And since then, it was actually somewhat, well, not quite since then, but that was when the growth of the field has started. Many statisticians have started calling themselves data scientists without consulting with computer scientists, right? And a lot of analytical programs started to get called computer science, data science programs, okay? So in 2012, Harvard Business Review called it the sexiest job of the 21st century, making data science a buzzword What's worse, in the same article, Harvard Business Review stated there are no programs currently systematically teaching data science. By data science, they meant this term that William Cleveland has proposed. If you received a mailing from us yesterday or today, then you have seen the link to that article where it's going on and on explaining that a data scientist is actually a data analyst. Okay, so Harvard Business Review was referring to the data analytic term of the data science definition. And then from that point on, we got a mess. Computer scientists were calling themselves data scientists, statisticians were calling themselves data scientists. There was very little overlap between the two. I will give you a few definitions, just bear with me. Let's read it out loud. Data science is a data-driven science, interdisciplinary field about scientific methods, processes, and systems to extract knowledge or insights from data in various forms, structured or unstructured. Now, another definition, data science is a systematic enterprise that builds and organizes knowledge in the form of testable explanations and predictions. The key word in data science is not data, it's science. Data science is only useful when data are used to answer a question, which is the key to analytics. In analytics, we form a question that we're trying to answer. So basically, most of these definitions talk about analytics when they talk about data science, even though, of course, it's an issue because computer scientists, people with algorithms and data engineering and much, much smaller data storage devices are still calling themselves data scientists. So where do we go from here? Do you want to be a data scientist? You do. First of all, it's fun. You will never get bored, provided, of course, you want to do something with data science. Second, it was from 2016 to 2020, it was #1 job in the United States. There is a link to the article that talks about the fact that the demand for the job is ridiculous and there is no sight in slowing down. The supply of data scientists is still low. And it's because the field of data science is still relatively new. You asked the question, why is data science field expanding? Well, that's because it's a field where we have so much data that we're trying to make sense of, right? People are realizing that we can analyze text data, that we can analyze numerical data, that we can do a lot of work with all that information around us. We finally have the computing power to make sense of this world. By the way, that's just a small trivia question. We have data, which what we typically think of data is in the forms of numbers, right? So we have categorical data, we can have ratio data or interval data, those are numbers. And then we have texts, like our speech and our writings, and maybe we have some images. So that's also data, right? So a question for you, for a data analyst or a data scientist, so far we're using them interchangeably, right? How much do you think, how much time and work is devoted to working with text data? So we have numbers and we have text broadly. So give me a number. Anybody? Somebody take a guess. 10%, okay. Anyone else? Pareto, 80-20, 5% text, 20 for the text. 95% of data that we work with as analysts is text data. I know it's surprising, just trust me on that, okay? All right, so lots of data to work with. And of course, with all the data, text or not, we want to be data scientists, right? So what do we want to do? And that's a question that some of you have asked earlier, and I will answer them when we get to the end. Let's talk about what we do. Do I call myself data scientist? Not really, only because I want to separate myself from computer science, but a lot of things that I do actually related to data science. So that's me, and I define myself as a social data and network scientist. So there is some part of me that is a data scientist. I was also the founder of a program called Applied Statistics with Network Analysis, and now I supervise this new academic program, Master of Data and Network Analytics. Why do I think I'm qualified to talk to you about data science? Because I've done all the things that qualifies data science. I started my professional career as a programmer, and I was doing a lot of SQL programming and database management and design. Then, in addition to SQL, I was programming in a variety of different other languages. I started with Fortran, don't tell anyone. I've designed computer software that was implemented at a company called Boise Cascade Corporation. And before I moved to corporate world and analytics, I was that computer science data scientist. Now, I've done a lot of data analysis, starting from about year 2000 when I started teaching basic statistics and then more advanced statistics. And then I started using more advanced statistics and I got my PhD. I started doing more analytics work. So I also know a lot about the analytical side of data science. So when I talk to you about what is data science, I can speak from both sides. I have designed computer algorithms and simulated lots of data and designed better data analysis algorithms. I've also worked with large amounts of data. And today we just presented the last project we have finished, analyzing socioeconomic impact of the entire automotive industry in Russia. And that was a massive big data analytics project. So I've done it both. So I can speak from both experience and my academic knowledge as a program founder and supervisor. We have two programs. Now, they're both in analytics, okay? We don't call them data science. We call them Master of Applied Statistics with Network Analysis, and we call them Master of Data and Network Analytics. Now, some of you have asked what kind of networks do we analyze? All networks. So it doesn't really matter whether you get your data from social media or you're analyzing networks of, let's say, phones. Any two dots that are connected with a potential of flow of anything between them, whether it's text messages or whether it is electrical current, they form networks. And if they form networks, then network analytic tools are applicable to them. There are different, I would say, slightly different applications. For example, we have a diffusion model when something is being spread through the network, and then we have a contagion model when something is being spread through the network. Do you understand the difference? Probably not. One of them has to do with the fact that a node, which is an actor or an electrical transistor, can transmit the data by making a decision. Do I transmit this data or do I not? So let's say you received a message from someone and you have a choice to forward this message to someone else or not. If you caught a virus, then you don't really have a choice of not transmitting that virus. You're 100% contagious unless you socially distance or wear protection in the form of a mask and gloves and whatever else, or the other person is fully protected. You don't make that choice. You can only protect the world from the virus, but you don't decide that, oh, I'm going to infect this person now, right? So see the difference? But other than that, it's the semantics of mathematics. We teach networks, and that's a big difference between our program and many other analytical programs out there. Our Master of Applied Statistics is an offline program, and our Master of Data Network Analytics is an online program offered on Coursera platform. Otherwise, they are identical. Now, I have shown this slide a lot, that job market prospects for network analytics is even more optimistic than for the data analytics market in general. I showed you the slide where they say that data science is still booming, growing job. I mean, that's wonderful, but network science within it is growing even faster.
So we are trying to prepare future analysts for that demand for network analysis when people realize the power that networks hold, not just the texts, but the networks. And this program really consists of three large components. We use applied data. What's the difference between applied data and, let's say, simulated data? Applied data are real. And because they're real, they contain lots of real problems. Today, we were asked a question about what was your biggest challenge when you analyzed an entire industry in the country of Russia out of 37 large industries. And we said, without even thinking about it, data. Data are the problem, both its amount, its cleanliness, its lots of different relationships hidden within. So when data are applied, when it comes from real life, it is so much more difficult to analyze it than the data that are simulated using some distribution and random number generator. We use analytics, which means lots of different tools to process that data. And again, it's emphasis on networks. In your studies, you will focus on theory, domain knowledge. You will learn to define a problem, because being a programmer without a problem to solve is not as interesting. You can develop another algorithm for analyzing networks, but if you don't have a good way to apply this problem to solving something in real life, then it's hardly useful. You will learn different software. We don't really focus on making you program all of your own code to solve the problems. There are other people, computer scientists, who have done it for us, right? You will learn some mathematics, but not a whole lot. We don't emphasize mathematics. We emphasize making sense out of results of your analytical work. And of course, there is a lot of practice, which means you'll be working with real life projects, with real life companies, with real life clients, and you will learn to do statistical consulting. So our program is very flexible from both the standpoint of the courses that you choose from and the level. We realize that people come from different backgrounds. Some of you might be a little bit more advanced, some of you less so. And when we have this issue with different backgrounds in the same audience, then some people feel like they're bored, yet others feel like they're not advanced enough. So we offer most courses on two different levels, beginning and advanced. And you can win Kaggle competitions. Kaggle is a data science community, even though, as we have shown in our previous webinars, our students have won the analytics competitions. You can select a wide variety of courses, but most importantly, you will get to work with best faculty all over the world. When I say best faculty all over the world, imagine you go to one of the top universities, let's say University of Michigan, just randomly. How many big names, like really big names, are working in data analytics in statistics department in University of Michigan? From my experience, I know nothing about Michigan, but from my experience, it's usually 1, 2, maybe 3. The rest are junior level assistant professors who are just trying to make their way through the tenure process. And in our program, we have brought faculty from universities all over the world, the best in their field. And it's something that you cannot find even at the best universities, because we don't have anybody on tenure track. They come and teach specific courses for us. For example, data mining is an excellent tool to have. Orange is an excellent software to do data mining with. Yanis Demshar wrote Orange software, and he's teaching the course for us. You can find more information using this link. Anna will send it to you in the chat. And we also have, somebody asked us about the certificate. We have a specialization on the Coursera platform that has 4 courses, and you can get a certificate for completing this specialization. It is designed for practicing business professionals who want to enhance their analytics skills. So check it out, and I will send that to you as well. Now, let's talk about data scientists. So you want to be the data scientist, yes? Nod your head, okay? Because you want to be a data scientist. It's exciting, all right? Now, what do you want to do? Have you thought, I mean, you think about data science. And remember, I asked you this question at the beginning, and you have given me lots of answers. And they was somewhat different, right? I suspect that if you are here for the data science using the answer that you have given me, then you probably want to do what you think data science is, right? So let's talk about that. So data science is an umbrella term. We have figured that out starting from 1974, when it was related to computer science and engineering, and ending with about 2001, when William S. Cleveland turned statistics into data science, right? We have a variety of different tasks within that one umbrella term. So of course, we start with the data scientists themselves. I took the definition from Northeastern, it's a well-respectable university, design data modeling processes to create algorithms and predictive models and custom analysis. So here data scientists are defined as designers of algorithms. They are programmers, in other words. They program the algorithms that analyze your data. Now we have data analysts, manipulate large data sets and use them to identify trends and reach meaningful conclusions, which is exactly what we call ourselves, right? So data scientists, I define as computer scientists. Data analysts is what our program offers. We teach you to work with data of any type, size, and composition to find that informed conclusion. I'm not done, right? Here's data engineers, clean, aggregate, and organize data. Basically, those are people who work with databases. We have business intelligence specialists. Those are people who work in data analytics and business analytics. Now, within our program, we offer a business analytics specialization where we teach you to apply the skills you learned in analysis to the real life problems in business settings. And then there's data architects, design, create, manage, and organization data architecture, which is basically enterprise application system that takes care of everything from hiring a person to processing all of the logistics and sales and interactions with suppliers and customers, and then maybe reporting the data to governmental sources. So that's all done within large enterprise systems. That's data architects. Now, those are all data scientists. Those are very different tasks. Now, to help you navigate through this, I also lifted a few images from KD Nuggets. It's a wonderful little website. Now, this is from 2015, but of course, it's still quite accurate. And KD Nuggets lists both of our programs, Master of Data Network Analytics and Applied Statistics with Network Analysis, as top programs in Europe. For the country of Russia, our program is selected as one of 4. And for the online programs, it's listed among probably half a dozen of programs that offer online education. So different data science roles. A data scientist, it's, notice the languages. It says R, SAS, Python, MATLAB, SQL, Hive, Pig, Spark. I don't think I know languages Hive, Pig, and Spark. I really don't, I don't think I've heard of them. R, SAS, Python, and R, SAS, and Python is something we teach in our program. SQL is being asked for, and maybe we will offer a course in database systems. We haven't done that yet. Now, here it's distributed computing, predictive modeling. It says storytelling, visualization, math, stats, machine learning. I'm not sure I agree completely with what this does, but it's just really computing, machine learning, and mathematics. So those are people who work for Google, Microsoft, Adobe, designing big systems, designing algorithms. Okay, that's a data scientist. All right. Now, here's a data analyst. It's a data detective where we collect, process, and analyze data using statistical tools. This is what we do. Okay. In our program, we are analysts. We are not computer things. Now, intuitive data junkie with high figured out quotient, that's a very good definition of what I am. I love to figure things out. I don't have a whole lot of publications, even though I have a lot of projects in a half completed state, means I have analyzed tons of data. I have performed some masterful analytics. I think but I haven't published because writing it up is boring, right? Okay, but figuring it out is fun. Languages are Python. Agree with that. C, C++, JavaScript, not so much, HTML maybe, okay? We teach that. Now, spreadsheet tools, for example, Excel, that's too simple, okay? Well, better than that. We teach about a dozen different software programs, SAS, Stata, Literal for those who do structural equations modeling. We do a lot of programming in R, and then some specific programs such as Orange or Payek for large network data. Math, stats, machine learning, maybe not a whole lot of math. And now the algorithms have gotten so sophisticated that you can do meaningful and very interesting analysis without emphasizing too much on mathematics. Data architect. I don't know a whole lot about data architects, honestly. It's really more of designing those enterprise systems. I was a part of that, as I told you, I was a part of that team at one point in time, but doing just a small part of database programming. It's just really creating those database systems, right? A little bit of data modeling, but mostly systems development. Data engineer, software engineer by trade. Those are people who write software, okay? Data APIs, data warehouses. It looks like Hive and Pig really are languages, okay? Well, Perl I heard about, Hive and Pig, not so much. And mindset, all-purpose, everyman, I don't think so, but hey, if that's what they want to be, all right? They are hired by Facebook and Amazon. And statistician. We are a lot less of a statisticians now because they are really collecting, analyzing, and interpreting data with statistical theories and methods. We do have computational social science specialization, and I guess they're more of statisticians and statistical theories, data mining, machine learning, a little bit of distributed computing if you have large data. And yes, all of those languages are SAS. We don't use SPSS, that's a bad term. And you can work for business applied companies, LinkedIn, Johnson & Johnson, PepsiCo. All right. So those are the 5 different roles. Now, the question is, how do you become one? If you want to be a data scientist, can't you learn it all? Well, it's actually a bad idea trying to be everything to everyone. Having experience in some of the well, 2 of the areas that I've described out of 5, I'm really bad now at any type of software programming. I don't do it anymore. But I can tell you that if you want to become good, you have to specialize. You have to pick one of those areas. You can't be an analyst, engineer, and architect all at the same time. If a program offers you skills in everything data science, run away, because you're going to learn a little bit out of nothing. And remember, there will always be someone else good at one task, but very good at one task. Pick that role. And here in the language of math is the motto of our program. I've said it many times, right? This is a formula for average. Be greater than average. If you want to be a data scientist, become a good one. It's a fun profession. It's an exciting profession. It will take for some of you to join a master's program and get additional education, or might as well become good at it. Okay, I mean, it's probably, easy for me to say just become good at something. No, you can become good at something if you pick the right program. So how do you pick the right program? That's what we're talking here about, right? So let's assume out of those 5 tasks, you have found the one you want to do, right? How do you become good? Well, it starts with finding a program. Name is important. You want to start with a university that has a name. And you want to select a pool of schools with that good name, no more than 5 or 6. Why? Because it's not only you who is choosing the school is also choosing you. And if you start applying to hundreds of schools, after the first 5 or 6, you will lose focus. You will start sending the same resume to everyone, the same cover letter to everyone. And as an academic supervisor of the program, I can tell you when I get the form letter. It has absolutely no meaning. It doesn't really show the person behind that application. Do I really have a professional here who wants to become an analyst, or do I have someone who sends out those blanket applications to everyone with hopes of getting in somewhere? And those that send hundreds of applications end up not getting anywhere. Why? Because they don't show the passion for what they want to do. So when you want to become a data scientist, you want to become a good data scientist, and you want to become passionate about that one thing that you're going to be best at. Second, cost is important. Most of these programs are not free. It's hard for me to say that paying for education is worth it because it's your money and you have to invest in that education, and then you have to pay lots of times loans back. And it's a difficult decision to make. So when you have picked those 5 to 6 schools, rank them by cost. I don't want the cost for you to be the only consideration, but you have to take into account how soon will you pay off your education? Will you get a job after you're done with school? When you're talking to schools, ask them that question. How many of your students are employed while students? How many of them are employed upon graduation? Where do they work? Those are important questions because just being a data scientist is cool, right? Everybody wants to be a data scientist. Well, where do those graduates work after they're done? How do their students perform? Will that cost pay off? Ask that question. Curriculum is the most important. It's amazing. Of course, our program gets confused with data science programs all the time for an obvious reason. I just explained to you why, right? Because data analytics is kind of data science. But it's amazing how many people apply to our program not even having looked at the courses we offer. They ask me 2 questions. Do you teach Python and do you teach SQL? Well, we do teach Python, and yeah, you can learn SQL. Lots of our students work as data engineers and they use SQL a lot. But that's not what you should be asking. You should be asking, which competencies do I get when I graduate from your program? What will I learn to do? That's the most important question you should be asking, because this is how you'll be looking for a job. What portfolio will I have when I graduate from your program? How many completed projects will I have in my portfolio to show to my potential employer? Those are the questions you want to ask, but curriculum is where it starts. Look at the courses just by the name. What do these courses offer you? Okay. Now, a good university will offer a variety of programs. And if you found a good schools, it's a range of programs in that data science field. HSE is an example. Well, HSE is a good university. Some call it #1 university in Russia. It still competes with Moscow State. Moscow State, of course, has lots of history, but it's definitely in the top 30. And from what I hear, it's #2 youngest university in the world. They say, they have that 50 under 50 universities rankings under 50 years old. So it's like in the top 5 of that list. It's definitely one of the best in Russia. So here's what HSE offers, and I may not know all of the programs, right? They offer program, of course, in data science at the Faculty of Computer Science. We have program in applied statistics at the Faculty of Social Science. We have program in data analytics at the Faculty of Social Science. We have program in computer vision, that's Nizhny Novgorod campus, and that's Faculty of Computer Science, I think, in Nizhny Novgorod. Program in econometrics, Faculty of Economic Sciences. We offer several programs in specialized analytics, such as financial analysis, business analytics at the Faculty of Economic Sciences, HR analytics at the HSE Business School. That's what I could think of top of my head. I think there is more. I think there is management and analytics for business at St. Petersburg. There is some analytics for social science and government in St. Petersburg. So there are additional programs. So basically, when you're looking for the data science program, if you found a university that has only one, that probably means they're not specialized enough. They don't give you enough of a specialization to do what you want to do. Okay, so decide what you want to do, then look at the curriculum. Here I'm showing you the comparison of the curriculum between two programs, Master of Data and Network Analytics, which is our program, of course, and Master of Data Science, which many people confuse us with. Notice the difference in courses. In orange, I have highlighted the courses that have similar names and similar meanings. When we talk about Python programming, I think Python programming is Python programming everywhere. We also offer programming in R, which is the language for statistical computing. Both programs offer probability theory. That's the mother of all computations in statistics. Both programs offer machine learning. Again, I do not know the extent of machine learning they offer. They have lots of algorithms, specific algorithms listed, like advanced machine learning. And we offer natural language processing. Everything else is different. Look at the Master of Data Science on your right. What do they offer you? Discrete mathematics, calculus, linear algebra, algorithms, and data structures. For statistics, which is data analysis, they offer one course. It's called Statistics Basics, where they teach you mean, median, and mode. I know because I know who teaches this course. Then, of course, they have software architecture. They have computer vision. They have deep generative models. So the Master of Data Science at the Computer Science faculty is that classical 1974 definition of what data science is. They're computer architects, okay? They're software architects. What do we teach? Contemporary data analysis, contemporary decision sciences, which is sciences that help you make decisions, linear models, network analysis. We have a variety of courses. Of course, that's our specialization. Bayesian data analysis, non-parametrics, covariant structure, categorical, multi-level, data mining. I think I missed time series. But we'll also have two seminars. One is computational social sciences, where we prepare students for PhD programs in social sciences. And one is business analytics, where we prepare professionals for working at companies like LinkedIn, Volkswagen, Coca-Cola, McDonald's, and so on. Both of these programs fall under the umbrella of data science, but notice how different they are. They teach you to do very, very different things. And that's important to understand. So the question to you, back to the definitions that we started with when we met, when this webinar first started, what is data science to you and what do you want to do? That should guide your choice of a program, and that should guide your selection of the education, even if it does not have that sexiest title of the 21st century called data science. Be a data scientist by what you do, not by what the program is called. If you want to learn discrete mathematics, calculus, linear algebra, probability theory, algorithms, software architecture, wonderful. Then this particular data science program is for you. But if you want to make sense of data, which is most of you have answered, then you are on the left side of this equation, okay? So I think I am done with that, okay? What do you want to do is the question that I'm leaving for you to answer. And I'm going to answer your question. The money slide. Mike is always a very supportive listener. I'm going to leave this right here. I kind of like this slide a little bit. All right, let's look at the questions you have asked. Is network analysis of data from a server or internet? Doesn't matter. It's any data that has a network structure, and network structure is two dots, right? Data analysis, traditional data analysis is analysis of single dots, right? We have those dots and then we just rearrange them in space somehow with using whatever tools. Network uses two dots, that's called a dyad, and the potential of a relationship between them, meaning something can flow from one dot to the next, doesn't matter what it is, okay? So network analysis is analysis of dyads, triads, and any other structures that transfer something to someone. So data can come from anywhere. So what else we have? Would regressions, linear logistic be classified as predictive models? An excellent question, and it depends on how you use regressions. You can build predictive modeling with regression analysis. And in fact, dynamic linear modeling is utilizing some form of regressions. So you basically, regression is a big field, right? So you learn linear regression probably in your basic statistics course. There are a general linear modeling approach where you can have different links in those regressions, and you can run those multiple models on time series analysis. To build predictions, you have to have data over time. So for that type, any type of regression analysis on time series data would give you the predictive modeling. I have read somewhere that HSE's Network Lab and Northwestern University equivalent in Evanston, Illinois may be sister organization in some way. Is that accurate? What is the nature of the relationship? The Network Lab, that's the laboratory that I founded and I still supervise. And Northwestern University have had a partnership agreement when our lab first started. Our lab was supervised by Professor Stanley, contractor who is the head of the Sonic Lab at Northwestern, was and still is his good friend and colleague. So this Nosh came over to Moscow and worked with us a little bit. Some of our students went on an exchange to Northwestern. One of them is still a PhD student there, Igor Zakhlebin, working with Nashir. And so we had that budding partnership at some point in time. That relationship is no longer active. We have published one work together jointly, the two researchers from both labs, but then we went our way and Northwestern kind of went their own way. And we still consider them partners for many things, so we can write to Nosh and we still talk to each other, but we don't have any projects in common. A role is growing in the US, at least as data translator. How do we translate the data findings into actionable strategy and tactics? Is that possible, sixth architect? Well, Norris, I could trust you to ask a question like that, right? So in our program, we start by looking for that translation. In other words, we start with a question that we're trying to answer, and we select a method and then collect data based on what is the question that we are after. So the translation comes naturally because we start with a question. So when we find an answer, it's already translated in the terms we want to do it in. Now, a lot of these translations come in the form of visualizations. We have an excellent course on business analytics and actually data visualization that's coming up and will be a part of our program. Lena Bielina, who is the professor of that course, had a master class on visualization. We have a webinar recorded. She showed just some very basic things, but they are actually quite impressive. So you'll need to learn to write reports. You need to show the data with visualizations to tell the story. We teach you the storytelling, but still you have to relate it to your audience and work with your audience in order to be able to translate the findings to your audience. So here I have some questions. I'm going to start LIFO, last in, first out. It's just a little bit easier. A medical doctor by education for the last 10 years, working pharmaceutical company in clinical research. Which course can you recommend for clinical research? Now, if you're looking, Dmitry, if you're looking for one course, then I would say that categorical data analysis is a way to go, combined with Bayesian data analysis. You kind of have to have both. We did have one physician with 20 years of experience in the medical field that also went into the clinical research. He finished our master's program, and his name is Andrei Hitrey. He is on Facebook. You can easily find him. Very successful clinical researcher, and he did his master's degree and his diploma using Bayesian analysis. What other questions do we have? Why the data science field booming across the world? Well, hopefully I answered this question because we have so much data and now we have tools, and companies are hungry for finding meaning in that data. So people who can do meaningful analysis are actually quite rare still, even though data science has become an educational program, right? It wasn't. when William S. Cleveland wrote his book, but or when Harvard Business Review wrote its article, calling it the sexiest job. But still, many more jobs are required, many more people are required. It's still a growing field, and I have not seen anything showing that the profession is going to be in a decline. So here's my problem with static. So that you understand the problem with static, today I'm experimenting. You see, I have this wonderful screen. I wanted to have a screen, and I'm using a different computer, and obviously it couldn't handle the sound. What are the prerequisites of the master's program? Does it assume that students know calculus, probability theory, linear algebra? No. We think that data analytics should be available to everyone. So we invite and we welcome everyone into our program if you know what you're going to do with education that we provide. We had some people who came to our program having, let's say, 2 degrees already, one in linguistics and one in law, never having analyzed any data. If they had any mathematics, it was in high school and long forgotten because they've been in the industry for a while. So we start from scratch in absolutely every subject. We teach you the skills that you need to have in order to master the subjects that are interesting and important to you. Every course is offered on 2 levels: basic, where we just literally go through the very basics. This is a node and this is a link. And then we have a course for advanced network analysis where I start with ERGM, exponential random graph modeling. So if you have very low background, we recommend that you take adaptive courses where we provide you with the mathematical and programming skills you need to do well in even the basic courses. Then you can select a range of basic courses that will give you the foundational skills in data analysis. And then you can select the more advanced courses in the same topics. For example, if you took basic or introductory time series analysis, then you can do advanced time series analysis, or you can do different topics. For example, you can just move to advanced machine learning if the introductory machine learning was enough, amply covered in other courses. Now, most of our courses are integrated and they somewhat echo each other. For example, when I used to teach applied linear models basic course, I showed some machine learning courses with regression in SAS. Now, SAS, of course, is a commercial program, but they offer a university edition, and it offers a module in machine learning where we teach the machine to find the function in the random data. So that's a little bit of machine learning. Then you can do a little bit more machine learning in some text analytics. So by the time you get to machine learning course, you already have the basics, you can move to advanced. But the answer to your question is we do not assume any background in mathematics, and we do not require you to have any. Amazingly enough, lots of our students who were, Japanese interpreters and came to write an amazing program that generates art. It's a machine learning program, generates art, and it's actually very good art. And the 2 colleagues opened the business selling T-shirts with their machine learning generated arts. So you can start with no background and then learn to teach machine to do art within the 2 years that we run the program. Which companies do you work with to build projects? Team students work in a project, students treated as interns at the companies, or do companies present the project and the students may or may not complete separate from any involvement with the company? An excellent question. So we have a variety of companies, actually. We run 2 separate structures. One is called a course in statistical consulting, where we make a broad call and make the consulting services of our students freely available to the broader community. This year we had 3 different corporate projects from different companies. L'Oreal, there was one company that, well, you've heard of L'Oreal, right? So that's cosmetics. There was one company that was making goat cheese, and that's a small farm next to Moscow. And there was a large bank. So very different industries that came to us with their projects that they wanted students' involvement in. As part of the course, students are all required to participate and work in groups. They're not required to work on all projects. So it ended up being that some students worked on some projects, some worked on others, but students can if they want to. Then there is a variety of individual consulting projects where individuals come to us with their data analytic problems, anything from design of the study to advanced analysis, and you act as consultants and help them out. So that's one structure. The second structure is called analytic workshop. Many students act as interns in this analytic workshop because an internship is required for our program. So they have to fulfill their internship hours. And again, it's different consulting. So companies that our students worked with include SAS, that's a completed project, Rosatom, which is a state energy corporation. We also worked now with Volkswagen Group, we worked with automotive industry. It's a large project. Those are some of the larger companies. We also have some smaller companies. And so students work on those projects if they choose to. It's always a choice. We never force anyone to work on anything they don't want to work on. Students are encouraged to work in groups, even though if you want to work individually, you may. And we also have internship agreements with several companies that take our students as interns to, and those are working agreements. As interns where you can just be employed. Many of those internships are paid, for example, with SAS Corporation, and then they're treated as interns, but then they can get hired at the completion of their internship. And students can complete company-based projects without actually being involved in the company. Yes, of course. Any other questions? You guys asked lots of questions today. Hopefully you have an idea of what you want to be, what you want to do as a data scientist. And I actually ran over, and that's probably because we had some computer issues. I apologize for that. Any other questions that I might answer? Did you get an idea of what you want to do with data science? And do you know how to pick a program? I want to say that HSE, all programs are good. They really are. But when you talk about data, business analytics, make sure you understand what business analytics you're going to, because we offer a business analytics specialization, which is data analysis for management and business. And we have a business analytics master's program, which is financial analysis. We do everything but financial analysis, and they do only financial analysis. So good luck figuring that out, right? So look at the curriculum, look at the courses. Any other questions? All right, thank you guys. You've been awesome. Thank you for sticking with me for over an hour, including some of our computer problems. Thank you for writing lots of comments and asking lots of good questions. Please write to us if you have any questions. Join our Telegram channels, come to our webinars, and we'll always be happy to chat and talk to you. Those of our regulars that come to almost every webinar, we're always happy to hear from you and happy to have you with us. You provide very insightful comments and encourage us to do better work. We love what we do. Hopefully you will become on our side of data science, which is data and network analytics. Join the channel. In the chat, Anna just posted the link for the Telegram chat, so you can join that, and then we have registration for the next webinar. All right, thanks everyone, and we'll have a recording. We'll clean it up a little bit, and hopefully we'll see you in one of the data science professions and in one of the data science programs. Have a good night, everyone.
Yes, thank you very much.